Today we are discussing another problem. The problem, it is. We are considering Bernoulli random variables x1, x2, x3, xn are Bernoulli, IID, Bernoulli 1p random variables, and h naught p equal to p naught. So we have to test the null hypothesis h naught p equal to p, h1 p equal to p1, comma p1 greater than p naught. The most powerful size alpha test for h0 against h1 is of the form, this is f1. This is f1 of x. That means probability of x equal x1 equal to x1, comma x2 equal to x2, comma etc. xn equal to xn when p equal to p1. Alternative hypothesis is true. Okay. In below we can see that this is the joint density when probability null hypothesis is true, that is f1 by f0. So in Neyman-Pearson lemma we are considering f1 of x by f0 of x. So instead of we write like this, and gamma if lambda x equal to k, and 0 if lambda x is less than k. Test function where k and gamma can be determined from expectation of phi of x under p naught is equal to alpha, that is probability of rejecting h naught when h naught is true. That is using probability of type 1 error. That is probability of type 1 error, expectation of phi of x under null hypothesis, that equal to alpha. Now let us closely look at lambda x. What is lambda x? Lambda x actually f1 of x by f0 of x. So that is given here. This problem is given here, and we can simplify that. We can club this two times, p1 raised to summation x, we can club that times, and the second times also we can club. So lambda x will be like this: p1 by p0 raised to summation xi into 1 minus p1 by 1 minus n minus summation xi. Okay. And since p1 greater than p0, so it is given that p1 greater than 0, greater than p0. So when we look, since p1 is greater than p0, p1 by p0 will be greater than 1. And this will be less than 1. 1 minus p1 by 1 minus p0 will be less than 1. So lambda x will be, since this lambda x will be increasing function of summation xi. Moreover, since it is less than 1, but at the same time here we can see that it is minus, coefficient of summation xi is minus. So when summation xi is increasing, this term, the first term will be increasing, and the second term will be increasing because it is minus and it is less than 1. So the entire function lambda of x can be considered as an increasing function of summation xi. So when we can reject the null hypothesis, we can reject when lambda x is greater than k. This is our criteria. Lambda x is greater than k means lambda is greater than k only when, that means lambda x is considerably large only when summation xi is considerably large, because lambda x is a function of summation xi. Okay, lambda x is considerably large only when summation xi is considerably large, because lambda x is a function of summation xi. So instead of writing like this, that is summation lambda x greater than k, that implies and implied by if and only if summation xi greater than k1, where k1 is some constant. Okay, so we can write, instead of writing this term we can replace with equivalent criteria? Yeah, so phi of x will be 1 if summation xi greater than k1, gamma if summation xi equal to k1 and 0 otherwise. And how can we determine gamma and k1? That are constants. That is using the probability of type 1 error. Okay, that is alpha is equal to expectation of phi of x under p naught. So that can be computed like this. That is 1 into probability of summation xi greater than k1 plus gamma into probability of plus 0 into probability of otherwise. So we need not write 0 into probability of otherwise. So just write the first and second term, that is probability of summation xi greater than k1 under p naught plus gamma into probability of summation xi equal to k1 under p naught. Okay, so that can be substituted here. You know, xi follows Bernoulli, so that Bernoulli random variable, so that the summation xi will be binomial random variable. That means summation xi greater than k1. That means summation xi takes the values k1 plus 1, k1 plus 2, etc. n. Maximum values n. This is the possible summation. So we can add that probabilities. That is probabilities of summation xi equal to k plus 1, probability of summation xi equal to k plus 2, etc. Probability of summation xi equal to n. So that is denoted like this: summation r from k1 plus 2 n ncr, because it is not binomial, ncr p naught raised to r, because we are considering under null hypothesis. That is p naught raised to r into 1 minus p naught raised to n minus r plus gamma into, here we have only one probability mass function, that is nc k1 p naught raised to k1 into 1 minus to n minus k1. Okay, so you can see that the most powerful size alpha test is independent of p1. So this test is, in this function phi of x, we don't have any p1, so it is independent of p1. So but we know that p1 is greater than 0. Okay, so we can, instead of saying h1 equal to p1, we can say that h1 is any p value in such a way that p1 greater than any p1 value for p1 greater than p0. So we need not to restrict a particular value. We can say the alternate hypothesis holds for p is equal to p1 for any p1 greater than p0. So so that means it is uniformly most powerful. Uniformly most powerful means if the test does not depend upon the parameter, then we will say that the test is uniformly most powerful. Okay, so it is uniformly most powerful test for p equal to p naught against p greater than p naught. So we have taken in this problem, they have taken a particular realization, that is take n is equal to 5, p naught is equal to 1 by 2, p1 equal to 3 by 4, and alpha is equal to 0.04. Then you can see that this is the most powerful test, and we can substitute the values. So alpha is, we have taken as 0.05, that is 5% allied significance, summation k plus 1 to 5, p naught is taken as 1 by 2, so gamma into 5 ck 1 by 2 raised to 5. Now here we have k is remaining. Okay, k is not given, so we take k is equal to 4. When we take k is equal to 4, we can see that after simplification gamma is equal to 0.122. You can simplify, you can do in your notebook, put k is equal to 4 and expand all these terms, and you will get gamma is equal to 0.124. Okay, so the most powerful size 0.05 test is to reject p is equal to 1 by 2 in favor of p is equal to 3 by 4 if summation xi is equal to 5, and okay, when we can reject when summation xi equal to 5 and reject p is equal to 1 by 2 with the probability 0.122, because we have obtained that gamma is equal to 0.122. Okay, I think we have already discussed a similar problem in the beginning itself. Okay, so with the probability 0.122 if summation xi is equal to 4. Okay, so since here, since k is taken as 4, we can reject when sum is 5. Surely we can reject when sum is equal to 5. But when k is equal to 4, here sum is equal to 4, we can reject the null hypothesis with probability 0.155. Okay, that is idea. So this is the problem that illustrates the most powerful test function, and you can in another way, suppose p1 is less than p0. So what will be the rejection region? Summation xi is less than k will be the rejection region. That means summation xi is considerably small than what is less than k. Okay, so the inequality reverses, and a similar methodology we can adopt for computing gamma and k. Okay. Okay, I think you got the idea. We have already discussed this type of problem in the beginning. Okay, so what is the in brief, what is the idea? We have to define this test function like this, and from this lambda x we can simplify. What is the reason for simplification? This is the reason, that is lambda x is greater than k if and only if summation x is greater than k1. So instead of that big expression, we will replace with this expression, and thereafter we will try to find out gamma and k1, the constants gamma and k1. Methodology. What is the function we are using to find gamma and k1? That is alpha. Expectation phi of x under null hypothesis. That is probability of type 1 error. Okay, type 1 error. Probability of type 1 error, that is alpha. Alpha is restricted to maximum 0.05. You know, in testing of hypothesis we have two types of errors. That is, one is type 1 error and type 2 error. We shall restrict the probability of type 1 error to at least to 0.0011 or 0.005, and we will try to reduce the probability of type 2 error. Equivalently, we will try to maximize the power. Okay, that is the test procedure, or that is the criteria for selecting a good test. So that technique is applied here, and in particular for a numerical realization, we consider these values and obtain the gamma value, and we have given the conclusion, that is reject p is equal to 1 by 2 in favor of p is equal to 3 by 4 if summation xi is 5, that is greater than 4, and reject p is equal to 1 by 2 with probability 0.112 if summation xi equal to 4. Okay, now we consider another problem, that is x1, x2, xn be IID normal n mu comma sigma square random value, normal random value. Both the mu and sigma square are unknown. We wish to test the null hypothesis that h0 mu is equal to mu naught comma sigma square equal to sigma naught against the alternative h1 mu equal to mu1 comma sigma square is equal to sigma naught square. So since this is a continuous density, so we can avoid the term what is that, summation lambda is equal to k. So phi of x equal to 1 if lambda of x equal to x is greater than k, and 0 if lambda x is less than k. So what is lambda x? Lambda x, you know, f1 of x by f0 of x, that is we are using. So instead of f1 of x, we put the likelihood function with the alternative hypothesis. and instead of f naught of x we write the likelihood function or joint density function with the h naught. So that is given here, and this is the function lambda x value substituted here, and so we have to find out this. Here we have only one constant, unknown constant, that is k. We have to determine k using this criteria. That is, we are using criteria in all problems. Okay, that means expectation of phi of x equal to alpha under null hypothesis. So what is lambda x? Lambda x is equal to this one. That can be simplified like this. You can take the expectation. We can expand this one. It is xi minus mu1 square. That is xi square plus mu1 square minus 2xi mu1. Okay. Divided by 2 sigma. And here also we can expand. That is xi square plus mu naught square minus 2xi mu I. So I will write that expansion because that is one step ahead. So leave the constant term, just other term only, consider the other term only. You know what is lambda of x? What is lambda? Lambda of x1 comma etc xn equal to here we have e raised to minus 1 by sigma square, minus 1 by 2 sigma square into summation. What is expansion? Equal to 1 to n xi square then minus 2 into summation and xi into mu1 plus n times mu1 here we can use mu naught. That is the step we have used there, and you can see that we can cancel 2 times. What are the terms? What will be the remaining term? this is the, so this we can simplify again. Mu1 minus okay, I think that is the step they have given. Okay, this 2 can be taken outside. Okay, we can remove this minus 1 so that it will be plus here and use sigma naught because it is given that. Anyway, you can see that this is the lambda x after simplification. 2 will be there, 2 will be there. Here we can see because we have already 2 here and only these 2 is cancel each other. So there will be one If mu1 is greater than mu0, then lambda x is greater than k only if this is e raised to summation xi. These are constants. Okay, so lambda x is considered to be large only when summation x is considered to be large. Lambda x is greater than k if and only if summation x is greater than k1. That is the idea. So from that we will compute the expectation of phi of x, that is alpha is equal to 1 into probability of summation x equal to x greater than k dash. Instead of lambda x greater than k, we can write summation x greater than k dash. So 1 into probability of this one plus 0 into probability of this is less than k dash, so that we can avoid. So this is the condition. So alpha is equal to probability of summation x greater than k dash. That is, we can standardize like this: subtract n mu naught on both sides and divide root n into sigma naught on both sides. So that this can be considered as set. That means set greater than k dash minus n mu naught by root n sigma naught. So alpha equal to probability of set greater than this one, but this is nothing but set alpha, because you know that alpha is equal to, from the standard normal curve, probability of set greater than set alpha on certain test. And compare with that, this set is greater than that set alpha is equal. So we can compare that. So we can see that this is set alpha. Okay, set alpha is equal to k dash minus n mu naught by root n into sigma naught. So from that we will get k dash equal to set alpha into root n sigma naught plus n mu naught. Okay, so this is a problem. And similarly we can treat when mu1 less than mu0, the inequality will reverse. Okay, the critical region, using probability of set greater than some set alpha. This area is point alpha. This area is alpha. Probability of set greater than set alpha is equal to alpha.
Now that we are for an army. Hey, very full of praise the Lord, Sudev, blessed are you among women.
And you know that since this critical region, or it is not depending on test function is not dependent upon mu1, whether this is less than mu0 or greater than mu0, the test function is not depending upon mu1. So we can use this test for any number greater than mu1, any number greater than mu1. Okay, mu1 greater than mu0. So this can be considered as a uniformly most powerful test. That means test is independent of the parameter. So for any parameter we can use the same test. That is the reason for calling it as uniformly most powerful. Okay. So in general we can write like this, whether this is less than or greater than. So moreover it is not depending upon sigma 1 square. So we can say that sigma 1 square is not equal to sigma naught square. So these are possible alternative hypotheses, null and alternative hypothesis for this problem. Okay. So there are a number of problems given in the exercise. You can do all these problems. try to find out the solutions or test. Anyway, today let us stop here, and in the next class we will discuss some more problem.